Hello. Today I want to have a look at a couple of displays. I've been looking for something dot matrix, not too high resolution, and just monochrome LCD. Is mostly for use with microcontrollers because you really don't want high resolution RGB displays because you can't update them very fast with a normal microcontroller. So I'm hoping these will work well. I believe they are 240 times 128 resolution, and the size is, let's do that in inches. Yeah, it's probably about 3.5 inches across. So it's quite a nice size. There are many other popular displays around, but most of them are way too small. Like the OLED displays is like really tiny displays, and you can't really, well, you can use them, but they're not that practical for most purposes. But the problem with this one, of course, is that it is chip on glass, and then it's got a backlight, and if you can see that, the connector, focus please, there we go. You can see the connector is just a strip that needs to be soldered down to a PCB, so it's not very prototype friendly. And then we have a backlight connector here, plus it needs a few external components to work. It needs a few capacitors because it will be pumping the voltage needed for the LCD, so you can't supply it with a single 3 volt, and then it will pump it up to whatever the LCD needs to work. So in order to try it out, I need to make a small PCB. So here we are in Eagle. I use Eagle for most of my project. I have a plugin called PCB Gcode that I will use to generate Gcode so I can CNC the PCB I'm going to be making. Anyway, so you can see here a really simple schematic. So this is the display connector we had a look at before, and basically we're just adding some capacitors. That's all this display really needs, and then we have the connections here we need to communicate with the display. So I believe it can run in both parallel mode and serial mode. So I'll need to have a look at that. I haven't looked into that much of the details of the data sheet. Anyway, the point of this little PCB is so it's easy to hook up to a breadboard, and then I can just use any microcontroller I like to play around with the display and get a good feeling for how it's actually working. If we switch over to the board, so this is the layout. It's just a tiny little board, 35 times 40 something millimeters, and I created this footprint that should match the display. And here we have our capacitors and one resistor, and then we just have a normal 100mm pitch connector here, a pin, so we can just plug it into a breadboard. So the next step is going to be to generate the G-code. I will run the plugin PCB G-code set up. Okay, here we go. So what I just want a single layer board here. So I want to drill so we get the holes for the pins, and then we want to generate top outlines. So I'll just accept and make my board, and then we get a preview here that will show us the tool path for when we're going to do the engraving. That looks fine, so just say OK to that. Now we have the G-code for the PCB. We can load it up in whatever software we're going to be using to control the CNC. So I've written this little piece of software I use myself, basically because I got tired of having to use a parallel port to connect my CNC, so I thought it was a fun little project to write a piece of software that will use USB instead. Anyway, okay, let's open the Gcode file we generated earlier in Eagle. Yes, here it is. So here we can see all the toolpath coming up. It's just nice to just have a quick look at it before. Let's just change that. Just have a quick look at it, see everything looks okay. Yeah, it looks fine. We can have a look at the drill file as well. Here we go, very simple. We're just gonna be drilling this row of holes over here. So that looks good. So now we need to prepare some copper clad single-sided FR4 or similar PCB material. The next step is to find a small piece of circuit board. So for CNC engraving, milling, it's good if it's reasonably flat. It's not so important for just a small tiny PCB. Anyway, so I'll just be using a small piece of this. What I do is I use some double-sided tape. So let's just try to get some of that on there. It's not particularly strong, but it just needs to hold the circuit board in place while we're doing the engraving. So just a few strips here. Make sure it stays in place. So I think that's enough. There's not going to be that much force on it. We're just going to be engraving, just removing the top copper surface tiny little bit. It's like less than 100 micrometer. We're going to go down into the PCB. Okay, so we have this ready. Then let's go to the small CNC machine. Okay, so I got everything lined up. So I just want to engrave the PCB over here. So we'll see how that goes. I'm just going to start it, and hopefully I got everything aligned correctly. Okay, there we go. It should take, I don't know how long it's gonna take, maybe 10-15 minutes. So I'm just gonna speed up the video. I usually run it pretty slow because it gives the best results. So I'll just keep it running here and then we'll speed it up. finally done drilling. It sure is a lot easier than manually drilling holes in a PCB. Of course, most people do SMD these days, but you still need a few holes here and there. CNC is a lot easier. Finally, I want to cut out the small board we have here. So I'm going to be using, just see if I can find a bit. Okay, here we have it. So this is a bit specifically designed to cut out FR4 boards. Let's get that mounted in there. Just tighten it a bit. Okay. So one thing about cutting FR4 is that, well, it's not very healthy, the dust coming out. Usually I have my CNC totally enclosed. You can see I got some foam material just to dampen the noise. But a good trick if you're going to cut out PCB, because that is really the worst operation, generating the most dust, is to use some water. Just add a little bit of water and all the dust will just clump together and you won't get it into the air. With the circuit board complete, it's now time to solder everything together. I hope you can see it here. Yeah, it looks pretty good. So I think the first thing I want to do is actually solder in the display, because it's probably going to be the hardest part to solder. The small capacitors and the pin header shouldn't be a problem at all. So I'll try to get some flux on here, and I'm not sure how to do this best. Maybe put a little bit of solder on the circuit board and then try to get it lined up and tacked in. I think I'll try that. So let's get some flux on there. Just need to find it. So since it's raw copper, and well, it will oxidize pretty quickly, so flux is extremely important. I'm just using some gel type flux here just to get it on all the pads. Okay, I'll try to see if I can get a little bit of solder on here on each pad without making too much of a mess. I can't see that. It's a bit hard with the camera. This might be too much. I don't think I've shorted anything yet. Create any bridges. Whoops, that was one. Okay. Just have a close-up look at that. I can't really see it in the camera LCD, so just gonna have a look here. Yeah, it all looks good. So, just putting some flux on here should make the soldering a little bit easier. And we need to align everything. That's probably going to be the hardest part, because it's very hard to see where it aligns the best. So I'm sorry, I just need to get off camera a little bit here so I can look down directly and try to tag one end in. Okay, so I think I got the one side tagged in. I just need to align it over here. It's pretty hard to see. Let's clean that tip. Okay, and we just check the alignment. Yeah, it looks reasonably good. So I'm just going to go along here and let's heat it up. It looks like it's flowing quite nicely. Okay. Just need to have a close-up look at that again. Yeah, it looks good. That was easier than I expected. Okay, time to get some components in there. Last one. And we're done. Here, got everything hooked up. So what we have here is a small PIC microcontroller. It's just on, I think they call it a PIC stick. It's a PIC 24 16-bit, small 16-bit with built-in program and everything. It's very convenient for breadboard prototyping, and there's really not much to it. Then we just got all the data and control wires hooked up to the microcontroller. I've done a bit of programming, and the only real issue I ran into was that I made a little bit of a mistake in the board layout. So there's a programming of the display communication mode, so you have a choice between big engine and little engine, and I got it set up for big engine. So basically that means all the bits were reversed when I send a byte to the display. A little bit of head scratching there, but a small botch wire and problem solved. Anyway, so I've written a little bit of code here. It'll just do some basic demonstration, some text, a little bit of graphics to show what the display looks like. Let's have a go. So I hope you can see that. It should be readable. So a little bit of text and some funky sine waves, just to show that, kind of to test the update rate of the display. It's pretty nice. And finally we have a full screen graphics effect, updating every single pixel, every single frame. It runs quite nicely. There's a little bit of, it's not super quick display. Well, I mean you can update it much quicker than this, but it just all turns into a blur like most cheap LCDs. So anyway, if anyone is interested, I will post the code somewhere. Schematic. I think it's very, very simple, and where you can get the display if you're interested. So I think, well, I have a project where I want to use this display, but that's probably too much to cover in this video. It's probably gonna be too long already. Also, I have another version of the display, this one right here. So the difference is this is black and white, opposed to this one is kind of blue and white. I haven't looked at this one yet, what it looks like, but I expect it will be very similar. Power consumption wise, the display with the backlight on full power, it consumes about 28 milliamps. It's not too bad, and the backlight is really nice and uniform. Actually, it worked out pretty well. So, well, I hope you enjoyed this. Any questions, just leave a comment, and have a nice day.